Okay, everybody, thank you for coming. I'm going to start the presentation now. And just to introduce myself, my name is Ben Lydon. I've worked for Hydro International for 6 years now. And when it comes to Texas, I am your resource for sizing, quoting, submittal work, design work, anything you need, you can reach out to me. As it pertains to water quality, I'll be able to help you with filters, separators, and we'll talk about all of that in today's presentation. But for those of you that I haven't met yet, thank you for coming, and I hope to speak with you soon. So we're going to cover a lot today, all surrounding filters and stormwater. I'm going to give you a brief introduction about Hydro International, who we are as a company. Many people are familiar with our products, but not always our company. So brief overview there. And then we're going to talk about the past and present and future of stormwater filters. Before we get into a design where we'll actually move through the TCEQ sizing tool with an example project. Because although I want you to understand the history of filters to appreciate what where we currently are and are headed. But the purpose for today is to show you the Up-Flo filter is now approved by TCEQ for use in Texas. We have a sizing tool and a maintenance manual to go along. And we're going to offer a easily maintained system with high performance that as a result gives you a small footprint to match your treatment needs. As far as this little housekeeping, there are going to be 2 polls in the presentation today where you can vote and interact. But there's also on your right, you should see a questions dialog box and a chat box. So please feel free to chat or add a question. I'll do my best to answer either right away, or if we're going to address it later on the presentation, I'll wait till we get there. But then you'll also have a handout. So during the design portion of today's webinar, we're going to move through the TCEQ sizing tool, which is Excel based. But in that handout link, you should be able to download it if you haven't already, so that you can follow along if you'd like on a separate screen or however you'd like to do that. And then at the end of the webinar today, there will be a survey. And if you fill out the survey, you'll go into a random drawing to win a $50 Amazon gift card. So make sure to take that survey at the end of the webinar, and then a PDH credit will be sent out for those of you that complete the survey. So that's all as far as housekeeping, but please feel free to ask a question or make a comment during the presentation, and I'll either answer it live or in a follow-up email just after we finish. So who is Hydro International? International is in our name, and we are absolutely an international company. But I always like to add, well, why do you care? Why is that important? It's important because we take practices that they're doing in Australia or in Dubai, the UK, wherever it may be, and we have employees that work in these different areas, and annually or twice a year we meet so that our America's Stormwater Division, located in Portland, Maine, is using not only the techniques that work in the US and Canada, but we're taking global knowledge and bringing it back to the US and Canada to incorporate into our own stormwater or wastewater products. You'll see our Stormwater Division is located in Portland, Maine, and we do have a wastewater division in Portland, Oregon as well. So Hydro International addresses all things water quality, as well as we have some flood alleviation devices and flow controls. But really, we don't sell pipe, we don't sell storage. We are a water quality focused company. So we pride ourselves on being water quality experts, whether it's stormwater or wastewater. We have a suite of solutions that we've developed on our own in-house, and we're able to accomplish those feats because we have a very own lab, wet lab located in Portland, Maine, where we continually can test and improve our products. So whether it's our separator or our filter, this isn't the first version of that filter or separator. We're on the third or the fourth version. So we're continually improving our products and tweaking them based on the field data we bring back or the practices we learned from Australia or the UK. Now, as far as our capabilities, stormwater management, flood protection, wastewater, combined sewers, all parts water. But what we'll talk about later today is our industrial water treatment and our monitoring and data analysis. And that's really the present and the future. I show a table at the bottom of this slide showing total solids because I would say sediment is the primary focus of any separator or filtering device. But sediment comes in all sizes, starting at your gross solids, which is really trash, but then your coarse solids and fine solids, which is really 50 micron to 1,000 micron. And I just want to give you an idea. When I say 50 micron, that's really, say, baking powder, very, very fine material. And then your 100 micron to your 1,000 micron is what we think about as, say, beach sand. So that's typically what separators are designed to treat. We're using filters when we get below that 50 micron threshold. And really, why the filters are required is because that sediment will no longer fall to the sump through gravity. So we can't use gravity alone for the removal portion of it. So that's when we're having to filter. So at Hydro, as I mentioned, we have a product for every size particle. On the left, you see our Hydro dry screen, which is really a next generation baffle box. So it's using baffle walls with a horizontal and a vertical screen to address mainly trash and large particles. Not only large particles, but large pipes and large flows. So our Hydro dry screen can accommodate up to a 60-inch pipe and stay online up to 60 CFS. So big pipes, big flows, big particles, big removals. Then we have our first defense and our downstream defender. Both are hydrodynamic separators. The difference between the two is that the first defense has an internal bypass, or the downstream defender is a full flow treatment device. The typical application for these separators are 50 micron and above, but also hydrocarbons, oils, and floatables. Then the Up-Flo filter, which is the focus of today's presentation, anything smaller than 50 micron, as well as metals and nutrients. And then we have a Stormscape, which is our LID filter. And if you'd like any more information on the Stormscape, please send me an email after today, and we'll address that. It's a point source filter, so it can be a pure infiltration device without a piping network. Works great for retrofits or matching streetscapes, but it's a bit different type of filter. So today we're going to focus on the Up-Flo filter. Now our first poll, and for those of you, Christopher that's out there, Will out there, I'm going to launch a poll where you'll all be able to vote, and then I'll close that poll, share the results, and then you should be brought back to the presentation after that. And so please let me know if for some reason that's not the case. But the first question I'm going to ask today, pull up the poll. Is which regions have you specified, if you have specified a stormwater filter before, and which of these regions have you done so? I'll give you all a moment to answer. Okay, looks like we have enough votes. So you should see the poll results now. 40% Austin, 70% in Dallas, Fort Worth, 10% Houston. And I'll be honest with you, I'm not surprised by the Austin results, but Dallas, Fort Worth, and Houston, from what I see, these are separator cities. So the first offense, the downstream defender, or maybe using storage as a solution for TSS removal. But when I am every day seeing projects after projects, where I'm seeing filters is San Antonio and Austin. And the reason for that is it's anywhere surrounding the Edwards Aquifer. So if you're in a recharge zone, that's when filtration is required. And typically, that's when I'm called to help with the design, is anywhere in a recharge zone surrounding the aquifer. But thank you for that feedback. Okay, you should be back to the PowerPoint. So just before we get into it, the last slide, I want to give you a little brief explanation of why I can intelligently talk on this topic, or as why Hydro can. Hydro International is involved with filters in the life of that filter more than any other manufacturer out there. It starts in our laboratory. So we'll touch upon it later, but we use a carbon blend of media for our CPZ filter. Now, why carbon? Why peat? Why zeolite? Well, we'll touch on that, but we not only design how the layout of the filter, but also what media mix is used. So it all started in Portland, Maine in our laboratory. Then at Hydro International, we offer a service and maintenance division. So we don't only maintain our filters, but our competitors' filters, whether it's a above ground detention pond, a manufactured filter, we're there maintaining them year after year, really getting a look at these filters that not many people do. Sure, they look good when they go in the ground, but what do they look like after 1, 2, 3, 5, 10 years of use? So we have a great understanding of the life of these filters. But then when it comes to industrial sites and the monitoring of these filters, because we're involved in industrial applications, and the difference with an industrial application is there's no regulatory approval you need to be used on a site. There's no BMP that tells an engineer which unit to select and why. On industrial sites, performance is the only thing that matters. So you have a certain concentration of copper or metal or sediment coming into the device, and before you get to your effluent, you require a certain amount of treatment to get that concentration down to an acceptable level. Now, the engineer, the site, they don't care by what means necessary, as long as you hit your limits. But not only the first time, the second time, the third time. Typically, these devices are monitored quarterly. So on industrial sites, we don't wash our hands of the filter and move on once it's installed. We're there 4 times a year, sampling, taking samples, making sure that they still hit their benchmarks to avoid costly fines. So through the lab testing, the service and maintenance in our industrial applications, we know more about filters and what they look like after 20 years of use than any other manufacturer out there. So speaking about filters, you can categorize almost any filter into one of 2 options. The shown on the left with your Brita filter, that would be a media filter, where the Brita filter uses activated carbon. Or on the right, your coffee filter. And what I'm talking about is that the actual filter, the fabric, that is using a membrane to withhold pollutants, particulates, and only pass water through that fabric or membrane. So we're starting with the past, the history as we go through the timeline. In Texas, you're very familiar with sand filters, or the Austin sand filter, at which we're storing water. We're passing water through sand and then gravel through a perforated pipe, because we all know there is no better purifier of water than the earth. So why we use sand and not a typical application is because we want a little bit more to replicate the process, but decrease the time required to filter. So we have shown on the left your typical sand filter. Now, the reason why we've moved away from sand filters, even though you'll see them everywhere, is they are above ground and they take up a lot of space and they're quite costly to maintain. So as you're driving by a hotel and there's a large hotel parking area and a large sand filter, if you could have put that filter underground, how many more parking spaces or rooms could you have had on site to just, which is more revenue for your customer and a better design. As far as the maintenance standpoint on these sand filters, what happens if they're not regularly graded, regraded, and maintained? You develop a wormhole effect, which water, as it's traveling through the soil, is going to take the path of least resistance. Now, over and over again, it does that and creates these channels where water is able to move through the sand and gravel to the perforated pipe without really having to work or be cleaned, because it develops this tube or channel where it's going straight to the perforated pipe. So what came next? Manufactured systems, cartridge systems. A few different examples of devices that are available on the market shown on the right in pictures, but common themes with these systems, although they worked, once they were installed, they were very hard to maintain for a few different reasons. This picture in the lower, when the media needs to be replaced, there were two options. One is to empty the filter, empty the cartridges, as you see here. They're vacuuming out the perlite with a vacuum truck, replacing the perlite themselves. You can go to Home Depot and get new perlite if you need, or get media through the manufacturer. But you're actually having to get inside the system, drain it of its water, and exchange the media yourselves. It takes a long time with a lot of effort. You can see to conserve space, these cartridges are packed next to each other. There's not much room to move through them, or even a lot of area to bring up the ones that need to be emptied and move the emptied ones to the back. So as you see in the bottom right, option 2 is bring all your cartridges to the surface, truck away the old ones, bring in new ones, put them back down and install them. But these cartridges can weigh up to 300 pounds. They can be thousands of dollars to replace. And with the media inside them, they're very heavy. So that detail on the bottom right shows a trolley system that is used to bring the cartridge. So this is under the manhole. And then you have a winching system coming down through the manhole cover to grab that cartridge, bring it to the surface, which may require special lifting gear to attach to the cartridge. It's a lot of work, and it takes a lot of time, and it costs a lot of money, where you're almost spending more on the filter once it's in the ground than to initially install it. So your life cycle costs just grow and grow and grow exponentially. So the first version of the Hydro Up-Flo filter was designed with maintenance in mind. This is our CPZ filter. So it's our media filter. You can see A and B, the carbon and the zeolite, what they look like there, zoomed in picture. And the module on the right shows that there are 2 media bags wedged in each module, and that's where treatment happens. Now the green is a Metalla that's really just used as a flow distribution device, so that we're using the entire area of the media, but we're also not having that wormhole effect that we saw in the sand filter. So we took what we knew about sand filters, we took what we knew about cartridge filters, and the photo on the left shows you the Up-Flo filter, with treatment in mind, and then service and maintenance in mind. We're going to go longer with each media pack due to the Metalla. And then once we do need to switch out the media packs, we've designed the center of each filter where it's going to be 7 foot from sump to surface, or sump to the top of the concrete, so you can stand up, you can stand in between modules. And what it would take to change out these spent media bags shown here with the new media pack shown here in white. You come in, you lift these covers off, put them to one side, and then shown here, you pull off the Metalla, both media packs come out, new media packs go in, put the Metalla back on, and put the cover on. So it's quick, it's easy, and none of our components weigh over 40 pounds. So there's no winches, there's no special lifting gear. It's designed that someone can hold a pack in each hand, hand them to the surface, roll them to the surface, whatever you decide to do. And then as far as disposal, the vacuum truck or any trash can accept the spent media bags. There's no hazardous waste associated with them. So it's a quick and easy cleanup. And that was Hydro's first version of the Up-Flo filter, focusing on maintenance. And why is maintenance important? For many reasons. But it would, just like any of these filters, compare them to your vacuum. It starts out clean. After you remove and remove and remove, it needs to be emptied. And if it's not emptied, what happens? It starts picking up trash, stops picking up trash. We have found that only 5% of filters that are installed in the US are properly maintained, regularly maintained. Typically, you get a phone call when water's coming out the manhole or backing something up on site, but it's not until that point, which is after the 12 months when inspections are suggested. And the pictures down below show you a 4-foot round Up-Flo filter at install after 18 months and after 36 months. And so when should you maintain your filter? We recommend an inspection after 12 months, and then you maintain as needed. So there's no one size fits all maintenance plans with these filters. It varies by site, but if you inspect after the first year, maybe you service after the first year, you say, oh, this could have been a bit longer. So then you do it 14 months later. And then if they're still not, they have a little more life in them, 16 months. And it'll take 2 or 3 maintenance cycles to really dial into when you should be inspecting and servicing. So the present, we have taken that CPZ filter, we kept the same layout, but we've now introduced that membrane filter, like you saw with the coffee filter, which addresses the CPZ filter is really good with metals and nutrients, where the membrane filter comes in as those very, very, very fine particles. We'll propose a ribbon or a membrane filter. And then the newest version of the Up-Flo filter is the EMC, the extended maintenance cartridge. And it takes that membrane filter, but introduces a backwashing system so that we're flushing it and just increasing the longevity of each ribbon. Which leaves us today with the Up-Flo filter that it has more approvals than any other filter in North America. And it addresses the 80% TSS reduction requirement by TCEQ. We use it on industrial sites. It does a great job with particulate and dissolved nutrients and very fine particles. How it works is water comes in through the left where the inlet pipe is raised above the outlet. So water comes in, your large particles settle to the sump. And then we have angled screens below each module to hold back leaves or any large particles that may blind the media packs or the ribbons to just increase that life cycle. Once the larger materials have been removed, water is forced up through the modules, of which there's a channel at the top. So water comes up through the media, the membrane, to the channel, which it can move downstream. And that is how we treat the first inch, inch and a half of rainfall, the intended treatment flow. During larger storms, your 100-year storm event, Shown in yellow here is a bypass hood, so that as the water elevation in the system gets up to here, it acts as a snout, so it won't pass the floatables or the oils, but it will go into bypass and let water move downstream. Now this filter can be designed with an internal or external bypass, and I'll show you a couple GA drawings later on to demonstrate what that looks like. Now what's important, and it'll come up later in this presentation, what's not shown here is we have a drain down device. So in between storms, if there was no drain down, the water elevation, the resting elevation would sit at the outlet pipe. What we do is we incorporate a drain down so the water elevation is set below the modules, so those media packs have time to dry out in between storms to fight against leaching or blinding of the media. So what filter is right for you? Well, you don't have to know that. That's for Hydro to decide. But here's a very good illustration of what that drain down looks like. But whether it's a media filter or a membrane filter, we'll be able to tell you through our experience and our historical projects. We can compare your site to another site. And then in our laboratory, we actually have column tests set up. So if needed, we can run a sample of your effluent through each one of our options and tell you exactly which media or membrane is best for your site, because even if it's a McDonald's in New England versus the West Coast versus Texas, it's going to see similar trash, but possibly the oils or the salt that it's bringing off the road is going to be different based on region. As far as our media blend or the fabric blend of which our ribbons are made of, how do we know, how did we choose what we're currently using? Well, it went back to our laboratory and testing, and more testing. We tested the loam, sand, zeolite, carbon, any media you could imagine, banana husk. We went through every media, we went through every fabric material to come up with the current blends that we're using today. And if you ever want some more information on what those tests look like, be happy to share them with you. And so for a case study, our Up-Flo filter was chosen at the Port of Tacoma in Washington. Now the Port of Tacoma is an industrial site, has excavators, large trucks, boats. It sees metals, it sees dirt, it sees sediment, runs the gamut as far as pollutants on site. So the Port of Tacoma, who did not have to meet, say, Washington DOE regulations, they got to choose whatever device they thought was best for them, as long as it got the results that would keep them from being fined. Now they chose the CPZ mix based on the turbidity and the zinc, the high concentration of zinc that they saw on site, and it would do a great job of addressing metals. But they also knew at this site they would be routinely, maybe every 3, 6, 9, 12 months. They weren't sure how soon, but they knew that often they would be replacing the media because of the amount of pollution on site that was regularly going to be pushed through this filter. So they wanted something that they could maintain themselves easily, have it be affordable, and they actually purchase extra media bags. So they are now doing this on their own regularly. And you see the amount of access the contractor had in the bottom right picture while installing the modules. Now this was a little bit different. That's actually one of our own engineers that was on site. When you are specifying an Up-Flo filter, all of the internal components will be installed at the precast facility, so that when it gets to site, the contractor is only responsible for grouting the pipes and bringing it to grade. Now, the last reason, which will bring us into the future of stormwater, why the Port of Tacoma chose the Up-Flo filter, was on the monitoring and the data analysis that comes with it. They have to sample 4 times a year, and based on the results, they are judged whether they're in exceedance and could possibly head towards a monetary fine. So before we get into the future, I have my second poll. When you are specifying or involved in a filter, do you require annual inspections or annual service to be completed? Okay, I'll give 30 more seconds for an answer. So we have 13% said yes, and it gets done. 63% yes, but it's not always done, and 25% say no. Now I'll tell you, as far as maintenance being required, being enforced, Texas does a very good job at requiring and enforcing maintenance, whether it's done through a service provider or the specifying engineer. But as far as comparing it to the rest of the country, Texas does a fantastic job surrounding maintenance. But how is maintenance currently being done? It's sending people popping manhole covers at site, using a sludge judge or some means to quantify if it's being done or whether it needs to be done in the next month, 3 months, 6 months. Now, what Hydro International is doing now, and on many industrial sites like the Port of Tacoma, we are now installing monitoring hardware into our filters, our separators. And what that looks like is a telemetry logger and a pressure probe. Essentially, what we're able to do is tell you how much water is in the unit at any given time, what the water elevation is, how quickly water is moving through the system, whether the sump is at 25, 50, 100% capacity, and it's taking all this information, moving through satellites and putting it on your smartphone or your laptop, whatever it may be, but you no longer have to look inside these devices to know what's going on. And so what would the benefits of this be? You know, you're no longer sending inspectors to site. Imagine if every BMP you put in the ground, you had a website you'd go to, and if it was showing a red dot, it meant it was its sump was set 75% capacity or greater, and if it showed in green, it was 75% or less. No more sending crews out. No more having to prove you're compliant, as you can just copy paste a link. And then also, it's not just addressing sediment, but you can see, did I undersize? Did I oversize? Am I in bypass more than I thought I would be? So you're actually able to track the performance of whether it's a separator filter that it puts in the ground. And so what does this actually look like? What would it look like? I'm showing the results of a monitoring device that we have on a filter in Washington, and the y-axis is showing the water level in inches, where the x-axis is each one is every 2 days. So you can see here, this green level is the resting water elevation, which, as I explained, is the elevation of that drain down filter. So this is the drain down inside the unit. This will be about where the media is, and then this solid red line is where the bypass is. So we can tell you whether the unit's at rest. We can tell you when treatment's being provided. So over this dashed red line means it's currently providing treatment. And then anything above this red line doesn't mean treatment isn't happening, but some water is being bypassed. So if you're sampling your effluent at this time, some of the water that's in your sample was not treated. So when you're monitoring an industrial site and you have to sample, you want to make sure you are not in bypass when you're sampling. So this is giving you a good indication of when you should be treating, when you should be sampling to get the best results. Now, aside from the water elevation, we can tell you when it's low. That was a historical record of when service happened. We can also tell you when there were storm events based on peaks. And then last, we can comment on performance. So drain down, what drain down is once the storm stops, how quickly does it take for the water elevation to get back to rest and drain the system down in the unit. Now, this is what a typical drain down time looks like. It's very quick, it's pretty short. But we can also find out when there's an abnormal drain down. So for some reason, the storm ended, and it took quite a bit of time for this unit to get back to rest, if it did, before the next storm. So if we look at the different elevations there, with this drain down here, we have treatment levels, we have the outlet level, and then the rest elevation would be down here. And that's when the filter drains down. So when we have an abnormal drain down time, what does that mean? It means this drain down is clogged. So you can see on the left, we show the clean drain down as it goes in, and then after 12, 24 months, what it may look like. And so we're now able to diagnose the filter without ever even getting into it based on the results we see that are coming to our software from those satellites. So we're able to diagnose from Portland, Maine, what's happening in Tacoma, Washington. So before we get into the design example, you can see how the direction these devices are headed, because we all know as currently, if it's not available on your phone, it has to be. Everything has to be available on your phone, and we're just making this technology even smarter so that we can save time and costs associated with it post-install. So now let's look at how to size one of these. When you all registered, again, you were able to download the Excel-based version of the Up-Flo Filter sizing tool. It's also on the handouts on the right, but if not, I have snippets, screenshots, so you can follow along. Now, this is your typical site in Austin, San Antonio. I've shown the filter in yellow and the storage system in blue. So when designing a filter, you have to know if storage is incorporated into the design or if you need to be a flow-through filter, meaning there will be no storage and reduction in flow rate before the filter is used. Now on this site, we're in Williamson County, a project area of 5 acres. Pre-development impervious is 1 acre, post is 4. We're going to treat the entire site through one basin, meaning one filter to address the whole site. And we have a net increase in impervious area of 3 acres, which will be going through our BMP. Now, per section 3.3 of RG 348, 80% of the increase in TSS load resulting from the development must be removed. So that's the goal, and that's what the sizing tool is designed to help with. So our sizing tool, when you download it, looks just like this, which you should all be very familiar with, seeing slightly different versions of this that are put out by the manufacturer. So step 1 or step 1 and 2 in this case, because we're only using a single, we're designing out of a single basin. So the site drainage and the site requirements will be the same. But step 1 and 2, in my example, show identical TSS loads, which you will see LM is the TSS load, as only a single drainage basin is being considered on this site. If the site has multiple drainage basins, you'll need to repeat steps 2 through 7 as we move forward for each basin. So you'll see here, the LM for this site is 1,741 pounds. And then the LM for the basin is the same thing. We're treating the whole site through one filter. So now we're going to go to step 3, which addresses the Up-Flo filter efficiency. And I've had a lot of questions here, so I'll explain a bit of the 78% removal efficiency you see. The Up-Flo filter has been assessed to have a TSS concentration reduction efficiency of 78%. Now you'll see this in step 3 of the design spreadsheet if you're following along, and that should not be altered. So this 78%, although we have to meet an 80% requirement, you do not change the 78% shown there. Although the required load reduction is 80% of the TSS mass is required, this is achievable by increasing the size of the filter system. So again, although the 80%, how's the best way to explain this? So the Up-Flo filter TSS concentration reduction is approved at 78%. The load reduction on site needs to be 80% of the mass, but it's important to understand that the mass reduction and the concentration reduction are not the same thing. So you can achieve an 80% mass reduction with a filter that's approved for 78% concentration reduction. So step 4 is where we calculate that mass removal. Step 4 calculates the Up-Flo filter's TSS mass removal, LR, based on the 78% efficiency rating. In the example, LM calculated in step 2 equals 1,741 pounds. And the LR, as we saw, is also 1,741 pounds. So at step 4, we've decided with this filter, we need to remove 1,741 pounds. Step 5, fraction of annual rainfall treated. Step 5 calculates the F value, which is the fraction of water treated on an annual basis using the equation 3.9 F equals LR over LM, which per TCEQ must be less than 1. So F is the fraction of annual rainfall treated. F equals LM over LR. And the lower F value you have, the less water that is required to be captured. So the lower F value, the less storage needed on site. And what we'll talk about for a flow through device is you're getting the storage requirement low enough so that the Up-Flo filter can meet it, meaning no external storage is required. You'll be able to store everything in the Up-Flo filter. And some cities, counties require more than 80%. 80% is the TCEQ standard, but if say you're required to meet 85% TSS, I've given a note here which is in the Excel document on the right. You'll see the right column. You'll see how to get greater than 80% TSS, they give you divide your desired percentage over 80, and then you're going to multiply that by your LM. So the example below shows if 85% of TSS was the requirement on this job, we'd do 85 divided by 80 equals 1.06, and then we'd multiply our 1,741 pounds by 1.06, and we would plug in desired LM at this basin, 1,850 pounds. So the Up-Flo filter can be used for TSS removals for more or less than the standard 80% based on our 78% concentration removal. And where you will put this to practice is in this step 5 by manually inputting whatever value you need for your LM at this basin. For this, though, we're going to continue with the 1,741 pounds, meeting the 80% removal requirement. Step 6 is where we address the capture volume. The rainfall depth, post-development runoff coefficient, and on-site water quality volume are all calculated values by the spreadsheet. So that work is done for you. But as I mentioned before, some of the total capture volume is held within the Up-Flo filter chamber. And you can call or ask me for exact volumes based on chamber size, but the logic is incorporated into this tool as well. So you can see the total capture volume on site is 24,781 cubic feet. So at step 7, we size the filter accordingly. In step 7, the spreadsheet calculates the minimum number of filters required to treat the TSS load, which is LR in step 5. However, due to the 78% TSS rating, the treated rainfall fraction in step 5 may exceed 1, which is the F value we talked about. In this case, an additional filter module can be added in 7A, which you see here, to get that F value below 1. So that is where an additional module is required to hit the 80% removal of mass. The spreadsheet will recalculate new values for F and the total capture volume based on the F value. And in some cases, it may be cost effective to increase the number of filter modules to reduce the water capture volume that's required on site, depending if you have the available space for storage or not. So what I'm saying is 13 modules to treat the site. We need 1 additional module to get our F value below 1. And so with 14 modules, we only have a now total capture volume required of 13,629 cubic feet. So you can see if we did 13 modules with 0 additional, so we were just a 13 module system, we would be stuck at 1 for an F value and need 24,000 cubic feet of total capture volume. With 14 modules, we meet the fractional requirement and we need 13,000 cubic feet of capture volume. So let's see if we go to a 15 module, or I'm sorry, jumping ahead. So that's 7A. Now below in your sheets, you'll see the last section, which is the Up-Flo filter sizing based on no storage or to be a flow-through device. Really what you're looking for here is this yes or no. Is there water quality volume required outside of the Up-Flo filter? So with 1 additional module, we're at 14 modules total. Total capture volume required 13,000 cubic feet. We don't have that within our filter, so yes, there is additional storage needed on site. If we add 2, we now have a total capture volume of 8,921 cubic feet. That's a 15 module filter, and we still require additional storage on site. 3, the same thing, but we see our F value goes down, our capture volume goes down to 6,900 cubic feet, but still we require an external storage system. But when we add 4, you'll see water quality volume required no. So we're now at a 17 module Up-Flo filter. F is down to 0.7 with a total capture volume required of 6,000 cubic feet, which we can store within our vault. So with 17 modules, no additional storage needed on site. At 13 modules, we had to capture, I think it was 16,000. So that means the 10,000 cubic feet is required to be stored in a chamber system, a concrete system, a large pipe, whatever it may be. So that lower part 8, you can increase the number of additional modules until that says no to remove the need for storage on site. And that, really, well, that is the end of the tool and how you'd use it to design with or without storage. Now you're asking yourself, so originally I needed, what was it, 14 modules to meet the water quality needs, but with 17 modules, I don't need an extra volume. Which do I do? Well, basically, a 1 to 6 modules we can fit in our 4-foot round version of the Up-Flo filter. So the 4-foot round just has an internal bypass hood here that can pass up to 4 CFS, and then you're getting treatment through the modules. When over 6 modules is required, we go to a vault that can be, this one shows the internal bypass, so your treatment flow goes through here, and then your 100-year storm can go up over the bypass, as we saw in that data analysis. So that water is untreated, but during that, it's pretty much clean rainwater anyways, because all of the oils and everything have been swept off the road surfaces during the first inch, which, is designed to be treated. So that first version, or the 14 module will be an 8x8 filter. Now we can go all the way up to a 76 module filter, 8x24, before we're using 2 systems in parallel. But the difference between that 14 module and that 17 module filter is 1 or 2 feet. So it was an 8x8. It could be a 6x12 to contain 17 modules. So now you're deciding, is it more cost effective to increase from an 8x8 to a 6x12, or should I keep it as an 8x8 and incorporate storage upstream of the filter? Really, it depends what that balance is. If it's an additional 1 or 2 modules, each module is about 1 foot. So you can see here, or I'll use this one as an example. This is a 14 module. If you had 13 modules to treat the water quality, but 14 would remove storage, your vault didn't even increase in that example, and there was no change. So always work with us, and we'll sort of tell you if this is a good application to remove storage, or if it's going to be required, keep your filter as small as possible. So that's wrapping up. We've talked about the history that got us to where we are now with our 3 different media options. And now I would say, as far as smart devices and monitoring, it's currently being done on industrial sites. It hasn't been commercialized to every project when there's subdivisions or gas stations going, but it can be. There just needs to be that need, which is driven by the engineer or by regulations or regulatory personnel. So as the requirement increases, that is when we will start to see common application of data loggers and sensors, so that we're not only installing but tracking and monitoring remotely how these devices perform. But again, if you have any questions surrounding the filters or even on maintenance services, you want us to maintain them for you, we do monitor quite a few devices in Texas and in Edwards Aquifer, and in one New Braunfels we were just out at. We'd be happy to bring you with us for one of these services so you can see how it's done. But really, for anything, reach out to me, Lydon@hydro-int.com, or you can see the link below for our sizing tool. You can Google TCEQ sizing tool, Hydro International, or you can check the handout. However you want to do it, plenty of ways to find it.